All right. Hey, everybody. Thanks, Dixon. Appreciate it. So quickly, I'll just do brief introductions. Dixon pretty much covered it. And then do a quick survey of you all so I can better understand where you all are coming from, maybe what stage in the data science project sort of spectrum you guys are in. So really quickly, as Dixon had said, I currently work at Databricks. I'm a product manager there. Wrote the book with Mate, was really lucky to be at the right place at the right time in order to help out on that book and learned a lot doing it. And really I wanted to just be 100% clear that this talk is very much informed by lots of discussions with our customers. I mean, it's really hundreds of discussions and the challenges that I've seen sort of throughout, right? So let's talk a little bit more about you all. And so just quickly, by show of hands, can I see the number of data scientists in the room if you just raise your hand? Okay. What about data engineers? All right. And team leads, that sort of thing? Okay. Looks like a lot of people are doing triple duty kind of thing. Awesome. So let's talk about the context of your organization. And so I kind of broke this into two kind of groups where there are some companies that are kind of scoping initiatives. There's some talk about what people actually aim to do, but no real machine learning in production. And so go ahead and maybe everybody can like close their eyes and then raise their hand if you're a little ashamed. But yeah, who's in this first group of currently scoping initiatives, no machine learning in production, or very, very little? Okay, that's about what I expected. And then I think naturally everybody's looking to grow, so maybe I can work on my category title. But basically this next group is, your company maybe has dozens of models in production. You've got a fairly robust team, but now it needs to go to the next order of magnitude. And so by show of hands, how many people fall into that group? Okay, fair number, cool. Great, so the context of this talk is really talking about these patterns for data science projects. And I really broke this into two different groups, which have three patterns each. So the first is organizational patterns. And what I mean by organizational is that none of this is happening unless you're in a research group or something like that. Then sort of everything's happening in a lab. But for a lot of us, this is actually happening on the ground. And we have to exist within an organization. And so the first pattern I see naturally is value, right? And we'll sort of formally go through, and I'll be precise in my definitions of each of these and talk about how it applies to data science projects as well. Alignment is the next pattern, and then lastly, discipline. Then on the other side, we have technical patterns. I'm going to talk about a hierarchy of needs with reference to data science projects. We'll talk about keeping things simple, and then tracking, really, how to make sure that you're keeping everything on the tracks. And so we'll deep dive into each of these patterns and apply it to data science projects. So the organizational patterns. The first one is value, and I really like to be precise in definitions, and so we'll go through, have a formal definition of each, but the regard that something is held to deserve, the importance, worth, or usefulness of something. And I think this is really powerful when you look at some of the organizations that exist today. And so the first organization I want to shine a light on is Stitch Fix. And Katrina Lake, CEO of Stitch Fix, is super driven on data science. And she has this awesome quote from this article that I'm going to share in a moment. And she says that data science isn't woven into our culture. It is our culture. We started with it at the heart of the business rather than adding it to a traditional organizational structure, and built the company's algorithms around our clients and their needs. And the reason why I think this is a good example of value is that there's really no confusion about what is driving value for the business. And I think that that's a really strong demonstration of leadership for her particular organization. And so I think it's really, I'll send out the slides after so you all can follow up and read these articles. And then the next organization that I wanted to shine a light on is Hotels.com. Matt Fryer actually spoke at last year's Spark Summit, and I pulled a quote from one of his from his talk, and he said, having senior level support is very valuable. our CEO in particular, is a great supporter of machine learning and sees it as a fundamental part of our future. And I think naturally we, as data scientists, we want to be in organizations that really value the work that's being provided. And I think a really key part of that is really demonstrating value along the way as you build out your particular project. And so, while value is important, it's pretty obvious. And so let's talk about how we can actually drive value in our organizations, and that's really through alignment. And so alignment, definition, arrangement in a straight line or in correct or appropriate relative positions, and a position of agreement or alliance. And I think a perfect example of not alignment is if we take a look at like standard data science job posts. So I was like cruising around the internet, trying to find a good example, and naturally like the first one I come across. So just read a couple lines, right? You got to have a PhD in computer science, 5 years real world or research experience. You got to have big data experience too. You got to do model development. You need to know 4 different programming languages, but if you know 2 of them, that's like really good. Understanding machine learning, et cetera. And then boom, you actually get on the job. Let's say you've gone through, you had done your research, and now you get on the job, and it ends up being Tableau, PowerPoint, and SQL. And like the first question you get isn't just like, hey, we really have to predict X, Y, Z. It's, hey, what's our daily active user count? What's our churn? How many people are using blank feature, right? And I think it's a total caricature between these two, but it's really scarily accurate. And that, I think, really is important when we're talking about alignment in the context of data science projects, right? I think one thing is that I've seen is really having a project formally prioritized makes a really big difference for data science projects. You can do kind of like the guerrilla warfare and work on a project that you think is really, really important. Those do work sometimes, but I think really having that aligned culture to help you actually move into production or really drive value for the company is pretty essential. I think you're going to need a lot of infrastructural resources along the way to actually achieve your mission of putting some data science into production. We're going to talk about that on the technical side. And really, you have runway and cover from your leadership to get where you need to go. And I think sort of speaking to the leaders in the room too, this applies that you have to cover for your team, right? I think because we don't have the most robust and totally mature tool set to build these things in a very repeatable and consistent manner, that covering for your team ends up being really, really important. And the key really here is that the organization has alignment on the value that data science really provides, right? And then lastly, my final sort of organizational one is discipline. And there are a lot of different definitions of discipline, and I pulled this one because I think it most accurately describes it, and it's a rule or system of rules governing conduct or activity. And I really like that definition because it's super simple, and I think, again, we'll start off with an anti-example. And here's a little comic. I'm sure you all have seen it before. And we're sort of going through, and the person asks, like, hey, this is your machine learning system. Yep, just pour in some data, you get some linear algebra, collect some answers on the other side, and keep stirring if it's wrong, right? And this is definitely something that, especially when people are trying to find an answer or prove something out that they really believe in, it's really easy to just like stir the data until it kind of makes sense to you. And so a little bit more formally, I think discipline in data science is a really focus on the results, not just the tasks, right? It's really easy to say, hey, we're going to build this recommendation system, and here are the features that we need to use, and here's actually how we want to like build the system to do our feature generation pipeline and so on. And at the end of the day, you want to just like help somebody find a better product, right? And I think really focusing on that end result is really powerful. And one of the customers I was talking with just last week framed this perfectly, that they don't define a data science project as complete until it touches the customer, or rather the customer touches it. And I think that that's really powerful because it's really easy as data scientists, as creators, we get super excited about what we're building. And it's like, hey, I improved this XYZ by 30%, right? And you want to share that with people. And somebody's like, cool, it's done. And it's like, well, I guess I have to do the logging, and then I have to get it actually deployed, so on and so forth. And I think not calling it done until it's in the hands of your users is a great way of just having those governing rules to help you deliver products and deliver value. The second point is really figuring out exactly what you want to do, and then keeping standards high, right? You don't want to drop off and cut corners. I think defining phases, demonstrating results along the way, a lot of this is just a formalization of things that I'm sure you all already do. And obviously don't just stir the data to get the answers that you want, right? Be principled. So let's talk about the technical patterns. I think this will cover a lot of interesting things. So the first thing I want to talk about is Maslow's hierarchy of needs. And so by show of hands, who else is familiar with this? I think this probably should be about everybody. And it defines a theory for human motivation, and it was quite some time ago. And the principle is that each base in the pyramid must be sort of completed or supported before a given human can move on to the next, right? And so you have to have food, you got to be safe, you got to have friends and family, high esteem, self-actualization. And so I had actually cooked this up for some of our sales reps and solutions architects a couple of years ago, where really defining a data-driven company hierarchy of needs, right? And here, I think it really follows the same principle, right? First, you're going to need data infrastructure, and preferably with low cognitive load for the team, simple end users, and line of sight to actually being able to automate things. I think then you're going to need kind of ad hoc data access. Maybe at this point you don't have any centralization of data, but at least you can kind of get at it, right? Then you're going to start building some data pipelines. This is going to end up being stable and repeatable and a much higher level of abstraction, so you can actually move on and focus on the real work that needs to be done. Then we have ad hoc data science. Maybe you're doing some experimentation, kind of just playing around with the data, right? And then production data science. Here's the Zen world where it's stable and repeatable, it's trackable, parts of the workflow are automated, line of sight to more automation. And so this, as I said, was something that I kind of cook up, and I was cruising around the internet because naturally I realized that I couldn't be the only one thinking of this, and I wasn't. And so this woman, Monica Rogati, really, really smart, she wrote a blog post about it last year, and she talked about the data science hierarchy of needs. And I think what was interesting is we had created ours in completely different spheres, right? But you can see a lot of the same patterns of collecting information, moving and storing information, getting consistent transformations, so on and so forth, right? And she has I would really recommend you read this article, because I think she does an awesome job explaining really what we as data scientists do. And she has this really awesome quote in there that I wanted to share. And she says, more often than not, companies are not ready for AI. Maybe they hired their first data scientist to less than stellar outcomes, or maybe data literacy is not central to their culture. But the most common scenario is that they have not yet built the infrastructure to implement and reap the benefits of the most basic data science algorithms and operations, much less machine learning, right? And so I think this helps you be realistic about that which you actually need to do before you can start really delivering value. And so, I think really to echo that, right, it says, you might say, how should I actually approach this pyramid, right? And so if we think about it, you can really go through and 1, 2, 3, 4, 5, just build out each one, and then, you're all done 7 years later. Or you can kind of move through it vertically and just say pick a narrow use case and make that successful. And I would definitely say that this is my particular recommendation. I think Monica actually echoes that as well. She says in that same article that the data science hierarchy of needs is not an excuse to build disconnected, over-engineered infrastructure for a year. Just like when building a traditional MVP or a minimal viable product, you start with a small vertical section of your product and make it work well end to end. you can build the pyramid, you can build its pyramid, then grow it horizontally. And I think that's super powerful. And one thing I really connected with too, being a product manager, is the goal here, right, is actually to like deliver value. And I think focusing on really delivering a narrow set of value and trying to expand out from there is just a great practice, because it's actually going to help you be successful and keep doing what it is that you want to be doing. Now, in the context of this pyramid, other folks have echoed similar things. So here's another paper. It may have come up today. Hidden technical debt in machine learning systems from Google Research. And they really point out some great anti-patterns here. And the first one they point out is glue code, and that there's lots of glue code to tie together generic components to kind of make it work within your world or your particular context. And they describe that as an anti-pattern. One that really stuck out when I was reading this paper is the word, or rather the words, pipeline jungles. And so just by show of hands, when you see pipeline jungles, is that something that makes sense to you or doesn't make sense? And raise your hand if it does make sense. Okay, that was kind of my expectation. When I read pipeline jungles, I was like, yes, I know exactly what that is. Because really, when pipelines or just things kind of evolve organically, it can be really difficult to maintain. And I think when you start looking at job dependencies and when you're building out really mature data pipelines, or immature data pipelines, I guess, in this context, then you end up really having to figure out how you're going to try and manage all these dependencies. So you turn to something like Airflow, but then boom, you've got some glue code, and it just sort of ends up being this patchwork quilt or hodgepodge of different tools that become pretty difficult to maintain. There's also a lot of abstraction debt, right? And this they describe as really a general problem in machine learning, in that there are a lot of different abstractions to kind of work with, right? And we don't necessarily have those fundamental primitives that might be applied in more of like a software engineer, or exist in a more software engineering centric approach, where you really have a firm grasp on what the core pieces of the puzzle are. And in machine learning, we're still really finding all of those. And so, naturally, I think really the focus here is to help force yourself to think holistically about solving that hierarchy of needs, right? So our next pattern is simplicity. I think a really good, plain, basic, or uncomplicated in form, nature, or design, without much decoration or ornamentation. I think another great talk by the guy who created Clojure, if anybody is familiar with that. He has a great talk called Simple But Not Easy, right? And I think that is a perfect way of describing true simplicity, in that just because something's simple does not mean it's actually easy. And I think this really comes up all the time in design. And so, by show of hands, who has heard of this principle or this phrase? Right, just about everybody. It's a great one, right? Keep it simple, stupid. And this one, I was looking at like the lineage of where did this actually come up, and it was this guy Kelly Johnson, who was totally prolific as an engineer. He was instrumental in just like something like 40 airplanes. And here's just like a sample of 3. And like the U-2 spy plane, like literally, arguably changed the world. And I thought that was totally, that's totally amazing. And I think that it's a great story for this principle, right? And I pulled a quote, or rather like a story, from Wikipedia. So Wikipedia, grain of salt. The principle is best exemplified by the story of Johnson handling a team of design engineers with a handful of tools, with the challenge that the jet aircraft they were designing must be repairable by an average mechanic in the field under combat conditions with only these tools. Hence, the stupid refers to the relationship between the way things break and the sophistication available to repair them. I think this is an awesome thing in the context of machine learning, right? Because when your model goes into production, debugging, like some deep feature generation kind of thing, or that being debugged by a DevOps engineer or something like that, is going to be really, really difficult. Think about the tools of the person that's actually maintaining it in production, what tools do they have, right? What knowledge do they have to actually be able to fix your system? And hey, maybe you want to just carry around the pager and deal with production outages, but I think really thinking about how, and really forcing yourself to kind of keep it simple so that, someone on the other side, when they're actually in the field deploying this, can know how to go about fixing it, or at least trying to better understand it, right? And, naturally this comes up in other papers as well. So this is another great paper, The Rules of Machine Learning, Best Practices for ML Engineering by this research scientist at Google, another highly recommended one, clearly like to read. And this one, he basically lays out, I can't remember how many rules, but going through it, lots of similar themes, right? And his rule number 1 is don't be afraid to launch a product without machine learning. And I thought that this was awesome if you think about the rest of the context of the talk, right? Earlier, we talked about driving value, right? And it should go without saying that given the context of organizations and that the theory and practice of actual job descriptions is totally different, that if you just write a SQL query and do a recommendation by literally just sorting by most popular or whatever it is, just to get something out the door, that can end up driving business value and help you get more runway to actually get the project that you want to build off the ground. Rule number 4, and so he breaks it up into these different sections, and rule number 4 is your first pipeline. And he says, keep the first model simple and get the infrastructure, right? And that, again, super powerful, focusing on simplicity, really focusing on actually driving the value, and figuring out the primitives, the core components that you actually need to build a robust system. And there was an awesome example of this from the Uber engineering blog. And essentially what they have here is they are working on customer service data. And so when tickets come in, customer service folks need to classify them and try and predict how best to serve them, right? And if you think about the scale of customer service, I've sent my fair share of complaints to Uber, I guess. And so along those lines, if they're reading these support tickets, doing document analysis, so on and so forth, and if you Google like fundamentals of document analysis, you're going to end up with cosine similarity, tokenization, lowercasing, TF-IDF, et cetera, right? All of these things are pretty fundamental when it comes to document analysis. And they still write a great blog post about it, talk about how they want to improve it down the road, but they're totally keeping it simple. And they're actually just focusing on actually driving the value there. And I think that was a really, really cool example because, at the end of the blog post, they say, hey, we're also doing this like deep learning thing and, maybe that'll make it to production. But at the end of the day, they're focused on just doing the simple one first and then moving on and moving forward. And so the last pattern that I wanted to touch on here is track. And so, I wanted to make sure that they were all nouns, and so it's like tracking kind of works better, but track, the act or process of following something or someone, precise and continuous position finding of targets by radar, optical, or other means. And I think, going back to this hidden technical debt in machine learning systems, really the thesis there is that the hardest part of machine learning systems isn't the actual machine learning itself, right? The machine learning is just that little tiny box in the center. And the really difficult stuff is the data collection, verification, resource management, serving, so on and so forth. And I think that MLflow provides a good thesis for actually providing this tracking value, right? And so Matej was talking about MLflow earlier on, but really it's composed of a couple of different primitives that allow you to work with sort of more generic components that are a little bit more pluggable. And I think the tracking part of it is the one that's I'm gonna focus on. And so really the thesis there is that you can centralize all of this tracking information to look at how things change over time, right? It could be hyperparameters, and you could do it from a notebook, from a cloud job, and so on and so forth. And then you can go back and actually query it, filter on particular parameters, look at how things changed over time. And that ends up being a really, really powerful tool because knowing where you guys had started, you can actually prove that business value along the way, right? Because you can demonstrate those improvements and then what that actually means for the business or the organization that you're working with. And so with that, those are my 6 patterns for data science projects. And thank you so much for listening.
We have a few minutes for questions. Does anyone have any questions for Bill?
It's a little bit also a question about Databricks, so I don't know if it fits in the session. I was confused in the morning keynotes. What of the components that were presented, the new products, is actually proprietary of Databricks and what is open source? And as you just mentioned, MLflow, it would be more specific. It's MLflow open source, or is it a Databricks product?
Yeah, great question. So MLflow is sort of this open source platform for being able to do this. And so you could take it on, it's Apache 2 license. So you could take it, run it on your own machine, and so on and so forth. I think just sort of similar to Spark itself, the thesis for Databricks, right, is that Databricks just wants to make Databricks the best place to run MLflow. And so from that, I think that's kind of the open source philosophy. Databricks has always been in favor of open source, and so really providing a lot of that value to the community is an important tenet. Yeah.
So let's suppose that you have to fix a lot of these things in your organization or on your code. Will you dare to prioritize those patterns in a certain way?
Good question. I'd say that the organizational ones are largely prerequisites. I think from my perspective, it really depends on the organization, right? And so I think that really delivering value and having that alignment is super important. I think you can get away with not being that disciplined for a little bit, but as soon as it's more than 3 people, you better know what you're doing, and you guys better hold yourselves to a high standard. From the technical patterns, I think the hierarchy of needs really lays it out, where you have to go through each of those steps. Otherwise, you're just going to end up in this totally unmaintainable mess. And I think not being able to simplify things, you're going to pay for it down the road. And so I think that they're largely prioritized in order now. Definitely.
Hi. What was the process of writing an O'Reilly book like? And do you have any feelings about updating the book, or do you feel the need to as the Spark engine evolves?
Got it. Very relevant to the talk. The process was burdensome, very difficult, really long, and extremely challenging. But overall, it was pretty rewarding. I think it's probably a little early to go through the updating process. It was totally focused on Spark 2, and maybe when we get to Spark 3, then start having discussions about updating it. I think, there's mention in the book in particular of the machine learning chapters and stuff like that. It's just hey, this stuff is moving so fast that as soon as these words are on paper, it's already out of date. And that is just that's kind of the nature of the beast. Once it's on paper, then it's on paper. And constantly writing a book is not what I want to be doing.
All right, Bill Chambers, thank you for your time.
Thank you.
Thank you, everyone.